call is now being recorded. Okay, before I'm going to start, let's have some review first of some important definitions. We have here a type 1 error. A type 1 error is committed when we reject a true null hypothesis, and a type 2 error is committed when we accept a false null hypothesis. And then the power function of the hypothesis test with rejection region R. It is a function of theta, which is the parameter theta, defined by beta of theta, and this is equal to the probability that our sample is an element of the rejection region indexed by our parameter theta. So the power function beta of theta is equal to the probability of a type 1 error, no? If the if theta is an element of the null parameter space. And the power function beta of theta is equal to 1 minus the probability of a type 2 error if our theta is an element of the alternative parameter space. So the ideal power function is 0 for all theta in the null parameter space. And that means the probability of a type 1 error is 0. And then we have 1 for all theta in the alternative parameter space. That means the power function is equal to 1, so the probability of a type 2 error is also equal to 0 in this case. But this ideal cannot be attained. So for us to have a good test, the power function must be near 1 for most theta in the alternative parameter space, and then near 0 for theta in the uh, null parameter space. So for this definition of the power function, we have actually three examples. So the first one, we have the binomial power function. Okay, we have that. The next, we have the normal power function. Okay, and then lastly, now we have here also the continuation of example 3.3. But we have an additional assumption here that we have a maximum type 1 probability, a maximum type 1 error probability of 0.1, and then we also assume a maximum type 2 error probability of 0.2. Okay, so we have three examples for that definition of a power function. Now let us continue that for a fixed sample size, it is usually impossible to make both types of errors probabilities arbitrarily small. So in searching for a good test, it is common to restrict consideration to tests that control the type 1 error probability at a specified level. So within this class of tests, we then search for tests that have type 2 error probability that is as small as possible. So we we fixed our type 1 error probability for a particular level, and then we're going to find the test having a or the smallest type 2 error probability. So we have these two important definitions now. For alpha greater than or equal to 0 but less than or equal to 1, a test with power function, okay? A test with power function beta of theta is a size alpha test if the supremum of the power function beta of theta, theta in the null parameter space is equal to alpha. In other words, the maximum probability of a type 1 error here is alpha. We get a value alpha here. Excuse me for a while. Unsa to Okay, sorry for that interruption. Let me continue. For alpha between 0 and 1 inclusive, so we have a test with power function beta of theta. It is a size alpha test if the supremum of the power function beta of theta for all theta in the null parameter space is equal to alpha. So for this definition, it actually implies, because our uh, the supremum is overall theta in the null parameter space. No? Theta in the null parameter space. So if theta is in the null parameter space, the power function beta of theta refers to the probability of a type 1 error. So ang pasabutan na karon, the supremum of beta of theta, where theta is an element in the null parameter space equal to alpha, that means that the maximum probability of the type 1 error is exactly equal to alpha. And the next definition for alpha greater than or equal to 0 but less than or equal to 1, a test with power function beta of theta is a level alpha test if the supremum of this power function beta of theta, theta, an element in the null parameter space, is less than or equal to alpha. It's almost the same definition above, but in this case, it says that the maximum, no, the maximum of the probability or the maximum probability of a type 1 error for our test is less than or equal to alpha. Yung maximum niya, hindi talaga exactly alpha, but it could be less than or equal to alpha. In other words, alpha here is an upper bound. Okay? It is an upper bound for all beta of theta in the null parameter space. So in other words, the alpha here is the bound for all uh, probability of a type 1 error. That is why this alpha here, ang common na tawag sa kanya is the significance level. Yung tawag niya, alpha is the significance level or level of significance. It is the maximum probability that we allow our test to commit a type 1 error. Okay? So some authors do not make the distinction between the terms size and level. And sometimes these terms are used interchangeably. But according to our definition, it says here that the set of level alpha tests contains, it contains the set of size alpha tests. Because the size alpha test in our definition is actually uh, in the definition of 8.3.6. Okay, so the methods of section 8.2 usually yield test statistics. We have the test statistics, and after that, we were able to determine the rejection regions based on our test statistics. And the the methods that we use do not generally lead to one specific test. Say, for example, if we consider the likelihood ratio test, it is the one that rejects our null hypothesis if says here that the likelihood ratio test statistic lambda of x is less than or equal to c. Yan yung mga condition na. But c was unspecified. So not one, but the entire class of LRTs is defined. One for each value of c. So the restriction to size alpha tests may now lead to a choice of one out of a class of tests. Okay, let us now consider example 8.3.7. We have the size of the likelihood ratio test. So in general, a size alpha likelihood ratio test is constructed by choosing C. Okay, since we want to determine a size alpha likelihood ratio test, based on our definition, we want that the supremum, alam natin, dapat hanapin natin, that the supremum of the beta of theta, where theta in the null parameter space, excuse me, naririnig nyo ba yung anak ko? Guys?
Wala na sir. Hindi po.
Wala. Sinisipon kasi siya, kaya ayan. Akala ko malakas masyado yung niya sa sipon niya ba. Okay, so we have that. When we're going to construct a size alpha likelihood ratio test, then we're going to use our definition. It says that the supremum of the power function over the null parameter space should be equal to alpha. Kaya ito. So this, by definition, we have that. Ano yung beta function natin? Because this theta is in the null parameter space, so yung ating beta function here is actually the probability that our x here is in our rejection region, where theta is in the null parameter space. Okay? Rejection region. So ano yung rejection region na? If we're going to use the LRT test, the rejection region is that the lambda of x should be less than or equal to c. So yan kaagad. Proceed to that. And that would be equal to alpha, according to our definition above. Kasi size alpha test, yung supremum ng power function beta of theta on the null parameter space, that will be equal to alpha. How that C is determined depends on a particular problem. So for example, if we're going to consider example 8.2.2, in which the null parameter space, big theta of sub-zero, consists of a single point that theta is equal to this value, small theta sub-zero. So we have a simple null hypothesis here. No, we have a simple null. And we have seen that this expression, x bar, the sample mean minus the population mean theta sub-zero, 1 over the standard deviation, 1 over the square root of n, we have that above is actually a standard normal. No? If theta, we take theta to be equal to theta sub-zero. Since we know that our x bar here is normally distributed, mean theta and variance 1 over n. Okay, so if we take theta to be equal to theta sub-zero, then we have that. This expression here, x bar minus theta sub-zero over 1 over square root of n, has a standard normal distribution. Okay, so in our example 8.2.2, the test actually reject. Itong note, so that the test rejects our null hypothesis if, ito yung nakita natin sa example 8.2.2, if the absolute difference of the sample mean minus the theta sub-zero would be greater than or equal to, pwede nyo ito balikan, negative 2 log of c divided by square root of n. So, if and only if, pwede natin gawin ganun, we reject the null hypothesis if the absolute difference of x bar minus theta sub-zero would be greater than z sub alpha over 2 over square root of n. Why? We can choose. The reason for this, it's because we have a two-sided test. We have a two-sided test in our example 8.2.2. So, so we let here z sub alpha over 2 to be equal to, yung ibig sabihin yan, yung z sub alpha over 2 to be equal to, pwede natin na, z sub alpha over 2 to be equal to the square root of negative 2 log of c over square root. Wala na pala yung square root of n. Okay, so we're going to continue this. We have z square alpha over 2. This is equal to negative 2 log of c. And then we have log of c to be equal to negative z square alpha over 2 divided by 2. And therefore c here, c would be the exponential of negative 1/2, and then we have z alpha over 2 square. Okay, pwedeng ganun. So where z sub alpha over 2 satisfies, it stays there, the probability that z is greater than or equal to z sub alpha over 2 is equal to alpha over 2. We have z as a standard normal. If we're going to look at the graph of this z, but red. Okay, this is 0. Say we have here z sub alpha over 2. So this refers to the probability that z sub alpha over 2, z is greater than z sub alpha over 2. Ito siya. Itong part na to. This area is equal to, or the probability that z is greater than z sub alpha over 2. That probability is actually equal to the area of that region, which is equal to alpha over 2. Okay, same thing. If we're going to consider on the other side, we have the negative of z sub alpha over 2. So this one, it refers to the probability that our random variable z is less than the negative z sub alpha over 2, would be equal to alpha over 2. Pareho lang yan. Okay? Uh, so the test, it says here, so the test reject our null if the absolute difference of the sample mean minus x sub 0 is greater than or equal to z sub alpha over 2 over square root of n, where z sub alpha over 2 satisfies. Okay, this is uh, the illustration. We have this graph that the probability that z is greater than z sub alpha over 2 will be equal to alpha over 2. So these tests, that reject the null, if this is true, we have this rejection region is the size alpha likelihood ratio test. Okay, so do you have any questions or clarifications to that? Kasi itong absolute value natin dito, it would consider two possible itong absolute value natin, the absolute value of x bar minus theta sub 0. So in other words, we have the two-sided test. We have the two regions there. So considering the z sub alpha over 2, then the probability that z is greater than z sub alpha over 2 will be equal to alpha over 2. And then it also satisfies that the probability that z is less than or equal to the negative of z sub alpha over 2 will also be equal to alpha over 2. That is why yung supremum ng ating rejection region will still be equal to alpha in that case. Okay, another example illustrating our definition. So for the problem described in example 8.2.3, then we're going to find a size alpha test. For this example, finding the size alpha likelihood ratio test is complicated. Okay, it's complicated by the fact that the null hypothesis H sub 0 is a composite hypothesis where theta is less than or equal to theta sub 0. In other words, it consists of more than one point. Well, in our first example, we have a single point and we have a simple null hypothesis. So the likelihood ratio test rejects the null hypothesis if the the minimum order statistic x sub quantity 1 would be greater than or equal to c. Okay, equal to c, where c is chosen so that the size, this is the size alpha test. But if we choose our c, where c is chosen so that this would be, based on our rejection region, this would be the size alpha test. And what should be the chosen value of c? C should be equal to the negative log of alpha over n plus theta sub 0. Then we can obtain that the probability, okay, the probability of this first order stat greater than or equal to c on, take note, theta sub 0 here, that's for our the maximum of our null hypothesis value in this case would be equal to e to the negative n c minus theta sub 0, and that will be equal to alpha. Alpha, kasi itong sa ating null hypothesis, theta less than or equal to theta sub 0. Ano yung maximum dun sa ating, if we're going to consider the supremum, di ba? The supremum of the, parang itong part na to, the supremum of the power function here, where theta is in the null parameter space, that is actually the supremum. Ito yung sinasabi niya. It's the supremum of the rejection region. Diba? Equal ito, according to our definition, the supremum of the probability that x here is an element of the rejection region, where theta is an element of the null parameter space. So ano yung rejection region natin? We reject, it says here, we reject if the first order stat is greater than or equal to c. So yan, diretso na tayo dyan. So that's the supremum. Ang ating theta in the null parameter space is that theta is now less than or equal to theta sub 0. Because theta is less than or equal to theta sub 0, so the supremum of this probability will just be equal to the probability of theta index of the the probability of the order stat, minimum order stat greater than or equal to c indexed by theta sub 0. Kasi ito yung maximum niya dyan. Theta would be greater. And that would be equal to alpha. That's according to our definition. Kung naghahanap tayo ng size alpha test, dapat yung supremum of the power function on the null parameter space would be equal to alpha. Tapos, kailangan talaga natin i-evaluate ito. How are we going to evaluate this? Ito yon. Ito yung ibig sabihin niya. Ito yung answer. So, that means that our alpha is equal to the exponential of negative n times c minus theta sub 0 will be equal to alpha. And from here we can compute that our c is equal to this expression. From this equality, we can obtain c dot dot dot, then c would be equal to that theta sub 0 minus log of alpha over n. So this C yields the size alpha likelihood ratio test. I'm going to elaborate more for this example. Sabi nga dito, finding the size alpha likelihood ratio test is complicated. Complicated siya. So paano natin hanapin yan? So balik tayo sa example 8.2.3. Okay? Para maintindihan natin itong sinabi ng book dito. So in example 8.2.3, we are going to reject. Makikita nyo naman doon sa solution natin doon. We are going to reject the null hypothesis if the first order stat, minimum order stat, is greater than or equal to theta sub 0 minus log of c divided by n. Where? Diba yung ating condition sa likelihood ratio test statistic that lambda of x is less than or equal to c, where the value of c is between 0 and 1 inclusive. So dito yung c between 0 and 1 inclusive. Yan yung nakuha natin doon sa ating example 8.2.3. Yan yung kanyang we reject our null if we have this statistic. Now, this statistic x sub the minimum order stat is greater than or equal to this value. So, if we're going to set the size to be alpha, maghahanap kasi tayo, no? Size to be alpha. So that is the supremum, according to our definition, the supremum of the power function beta of theta, where theta is in the null parameter space, equal to alpha. That's according to our definition. So if and only if, it says here, the supremum of the power function beta of theta, where theta here is less than or equal to theta sub 0, kasi yan yung ating null hypothesis, equal to alpha. Now, yung power function beta of theta will be equal to the probability. Okay? Yan yung power function, the probability that our x is an element in the rejection region. Yan, according to our definition a while ago. So, ano yung rejection region natin? So, the probability that our sample mean, not sample mean, the first order stat would be greater than or equal to theta sub 0 minus log of c over n. Okay, this is based on example 8.2.3. Take note, ha? Ito siya, yung red, based on the example 8.2.3. Kung titingnan natin dyan, parang itong C dito, kasi minsan nagko-conflict yung mga notation niya. Lagyan ko ng color ha para makuha ninyo. Itong C dito, actually ito yung nire-refer niya. Ito siya. Na merong C din dyan. So dapat sana, iniba niya yung kanyang letter ginamit. Say, dapat x sub 1 greater than or equal to k. Yun ang dito sa itaas, no? X sub 1 greater than or equal to k. Kasi doon sa ating definition ng likelihood ratio test, the lambda of x is less than, no? The lambda of x is less than or equal to c. Ito dito c pa rin yung ginamit niya. Naintindihan nyo ba? Na itong c na nire-refer dito sa problem na x sub 1 greater than or equal to c, it's actually this value, theta sub 0 minus log of c over n. Yan yun actually ang nire-refer niya. Because in example 8.2.3, ito yung rejection region natin. Ito yung rejection region natin. Ito yung nasa green na yan. Pero ang pagkasulat dito, reject if the first order stat is just simply greater than or equal to C. In example 8.2.3. Okay, so I hope na okay. Ang justification niya ngayon dito, since theta here is a location parameter for next na tayo, dito na tayo follow. Since theta is a location parameter for the minimum order stat, so the probability that x sub 1 greater than or equal to c indexed by theta would be less than or equal to the probability that the minimum order stat greater than or equal to c indexed by theta sub 0. Because, no, that's because of theta is less than or equal to theta sub 0 in our null hypothesis. Kung titingnan mo yung null hypothesis, ito man yun. Nasa null hypothesis, that theta is less than or equal to theta sub 0. So, totoo talaga yan. And then, thus, we obtain this value until we're able to get the value of C above. Ang pinakamahirap dito na part, paano na-solve ito? That the probability of x sub 1 greater than or equal to C indexed by theta sub 0 is equal to e to the negative n C minus theta sub 0. So to solve that one, recall pa rin yan sa previous natin na example na ang PDF, in other words, the PDF of x, the minimum order stat, or sometimes you call it as the likelihood function of x sub 1. Pwede natin sabihin ng likelihood function na x sub 1. Ito yun. Sabihin natin f of x sub yan. This would be equal to given ito sa previous example natin, yung sabi ko na i-try nyo daw to, baka lalabas ito sa exam. Ito yung kanyang PDF, ito yung hinahanap. Try to find this PDF. Actually, you're going to use the formula that we have in our order stat, yung mayroong n factorial, then you multiply it by the PDF of x, then you multiply it by the CDF of x raised to j minus 1, then times 1 minus the CDF of x raised to n minus j. Yun yung formula natin sa order stat natin. So, ang nakuha natin dito, it's actually equal to, we have n e to the negative x quantity 1 minus theta. This is for theta less than or equal to the minimum order stat, and then 0 if theta is greater than. Okay? I-try natin ha. Tingnan natin balik. Check natin kung saan yun. Kung nandito pa ba na sa ko. Sample 2 above. Check natin kung makita ninyo. Ito. Okay? We have that. That's the PDF of our minimum order stat. X sub quantity 1. Okay. Balik na tayo. Okay, we have that. So for us to compute, gamit tayo ng ibang color. So for us to compute the probability that X sub quantity 1 equal to C theta sub 0, parang pangit ito na color, green. Ito lang green. Okay, so this would be equal to what? The integral from C, okay, from C to positive infinity, we have the PDF of X sub 1, n e to the negative X quantity 1 minus theta d X quantity. Parang ganun yun. Yung ating, so if we're going to, then we have now n e, may kulang pala tayo dito. Sorry, may kulang tayo dito. N e to the negative n. Ito pala yung kulang. Okay, we have that. So, may kulang yan dito. Infinity, so we have n e to the negative n. Okay, we have that. So, e to the n theta, pwede natin ipalabas yan sa ating integral sign. Then we have the limit of the integral from c to b, since we have an improper integral. So, maiiwan sa ating integrand, we have e to the negative n x of 1 d x of 1. X yan ha. As b approaches to positive infinity. So this would be equal to n e to n theta. And then if we're going to get the integral of that, we have now e to the negative n x quantity 1 over what? Over negative n. Evaluated from c to b, b approaches to positive infinity. Okay? So this is equal to n e n theta, and then the limit of e to the negative nb. Pwede na pala yung mag-cancel yung n. So, palitan na, erase na tayo dito. This will be equal to negative. Okay, negative. So, nb, then minus e to the negative nc. As b approaches to infinity. Okay, so negative e and theta. So we have the limits of 1 over e to the negative, positive na, and b approaches to infinity minus, hindi ko na lang ibaba yung sa, wala namang b dyan sa second term. So applying now the limit, we have now e, negative e, and theta. So that would be 0 minus e to the negative nc. And then if we're going to multiply, we have negative e. So what do we have? Factor out negative n sa taas. The result would be c minus theta. At theta sub 0 pala to. Para wala na lang, no? Ilagay mo na lang natin na theta na lang to. Okay? Theta. Kasi theta yung ginamit ko. So this implies that the probability, kung theta sub 0 tayo, we have x sub quantity 1 greater than or equal to c, it would be equal to negative e and c minus theta sub 0. Okay, so we have that. Ito. Okay, guys. Now, we're going to compute for alpha. So, equal yan. Ito, paano natin i-color to, no? Itong orange na lang, ito light green. Ito, at saka ito. Pareho lang naman yan. So, equal to alpha. And then we have already that equality now. Then we're going to compute for C. So to compute for C, we have alpha equal to negative E n negative C theta sub 0. So if and only if ba't may? Tama ba to? Ba't may negative pala? Sorry. Ba't may negative? Parang mali ako pagka may negative siya. Yeah. Negative times negative maging positive. Itong part na to dito. Mali ako, no? Erase ko muna. So, negative times negative. Kasi 0 to, negative times negative. So, maging positive na pala yan. E. Okay. E. So, here, it would be equal to e to the negative n. So, ito walang negative. So, we have log of alpha is equal to negative n c minus theta sub 0. And then, so we have now log of alpha over negative n, it's equal to c minus theta sub 0. So this further imply that c is equal to theta sub 0 minus log of alpha over n. Okay, so that is actually the value of C that would yield our size alpha likelihood ratio test. O, kung titingnan nyo dito, no, sa example 8.2.3 natin, kasi itong part na to, ilagay natin ng pink na lang ha, ito yung C, yung pink na yan, ito C pa rin ang ginamit yan, mga C ang ginamit. So we have that C. Eh dito sa atin, itong C pala, ito yung nire-refer niya. Yung pink na yan, yan yung C. So sana dapat palitan niya ng K para hindi tayo malilito. Pero C man yung ginamit niya. Kaya kung titingnan mo dito, no, yung C value, theta, kung K ito, kunyari kung K ito, that's theta sub 0 minus log of alpha over n. We know that our alpha here is greater than or equal to 0 but less than or equal to 1. Ayun, halos pareho lang man yan. Parang napalitan. Kung titingnan mo, yung C doon, log of C, sa problem dito, it refers now, yung C sa example 8.2.3, that actually refers to alpha in this example. Okay, so any questions or clarification? Bali, pag-construct mo ng size alpha likelihood ratio test, you're going to establish that the supremum of the power function on the null parameter space is equal to alpha. Ito yung i-establish mo. And then, based on your likelihood ratio test statistic, makukuha mo naman yung rejection region mo doon. Kaya nakalagay dyan yung rejection region. Since our rejection region, we have this test statistic, the minimum order stat. Then for us to be able to compute this probability, we need the PDF of our minimum order stat. Yan, given yan sa violet o sa purple, yung PDF ng minimum order stat. That's why we're able to determine this probability, and that it will be equal to alpha. Hence, we're able to determine what should be the value of C. Kasi, sinabi ko kanina, dito, yung likelihood ratio test statistic natin, na lambda of x is less than or equal to C. Yan man talaga yon, C. Na nakasulat dun sa definition natin. We have a lot, no? Malaki masyado ito na class because we have not specified the value of C. No, C was not specified. So how are we going to specify C? So that we're going to determine the likelihood, the size alpha likelihood ratio test for this problem. So itong example na to, nakuha natin yung value ng C. Ganun din yung sa first example natin. Ito yung first example, nakuha natin yung value ng C at the same time on the second example. Any questions or clarifications? Ang flow, no, kung gusto, ang flow sa pag-solve dapat, no, sugod mo ni na ako yung arrow nga violet, sugod mo na. Pagkahuman, makuha ni mo ni na equality. Where, ano rin ka, where, pag-compute aning light light pink, light green diana ang pag-compute ana nga probability morning dark green nga solution. So nakuha na nato na ang probability ana equal sa exponential, then equate mo na sa alpha, mo na dahil ni nakuha na dahil nato ang C. Pag dire-diretso ba from here, then subalik ana dan padulong dito ana. Ang kuan man gud sa ang flow sa solution din sa book, ningon naman siya na the likelihood ratio test statistic rejects the null if this is true. Now we have this rejection region where C is chosen so that this is the size alpha sets. So C is chosen. C is this, then this is true. It is equal to alpha, and this is the and this C yields the size alpha likelihood ratio test. Para siya makapabaliktad ang iyang pagka-explain. Dapat kung gusto niyo para makakuha mo ng ang flow sa answer na, you start with the definition. Ano unsa din ang size alpha likelihood? Nag-ingon ng definition na ang supremum sa power function beta of theta on the null parameter space equal to alpha. Mo nang mayon ako kanang nasa purple. And then you obtain your C that will satisfy this. Okay? We have this note of notation. In our first example, we use the Z sub alpha over 2. We call that as the cutoff point. Naintindihan niyo naman yan. Parang tawag yan. That's actually the upper percentile point such that the probability of the standard normal random variable greater to that Z sub alpha over 2 or Z sub alpha will just be equal to alpha over 2 or alpha respectively. That would be also true for if we have a t distribution, a chi-square distribution. We have itong mga common na mga points ang ginagamit natin. Ito. Yan. Ito for the chi. Okay, let us proceed. Next example, the size of a union intersection test. When we say union intersection test, itong union, it actually refers to the union of our rejection regions. Itong intersection, this is actually the intersection of the partition in our null hypothesis. No, intersection in our null hypothesis. So the problem of finding a size alpha, when you say size alpha union intersection test, in example 8.2.8 involves finding the constants T sub L and T sub U such that, ito nga yung nagsisimula. How are you going to find the size alpha likelihood ratio test? That means it's actually, diba ito yung natin? It's the supremum of the power function where theta is an element in our null parameter space. So that is equal to that. Equal to alpha. Dapat equal to alpha. Pero what is our beta function? Equal. Pwede natin sulat. The supremum of the probability that our x here is in the rejection region. Theta is an element of the null hypothesis. Or rather, the null parameter space equal to. So ano yung rejection region natin? Di ba? Itong yung rejection region natin. Ito yon. If this expression is greater than this for the first one-sided test and this less than this for the second one-sided test, you take now the union of the rejection region. So that's why the supremum of the probability of this union of rejection regions. Now X is an element of R, element of the rejection region. So union of these two rejection regions, theta element in the null parameter space, and that would be equal to alpha. So, but for any mu and sigma square equal to theta. This is actually a vector theta in our null parameter space. But we are actually estimating mu here. In this example, for this example, the sigma square here is unknown. The sigma square here is unknown. Pero pag ang sigma square for this problem is known, iba yung answer dito. So unknown ito. So we are estimating rather hypothesis we are testing the mean. We are actually we are na hypothesis ano nga yun? We are hypothesizing the mean mu equal to mu sub 0. So ito yun, unknown yung ating variance, and thus we have this having a student t distribution. Kasi unknown yung ating variance. Remember, ito lang yung gusto ko i-emphasize dito na part. Remember that z, the ratio of this, z, having a standard normal distribution, and then the square root of u divided by its degrees of freedom, u having a chi-square distribution with k degrees of freedom, this has a t distribution with k degrees of freedom. So in this case, ang z natin dito, the z refers to, blue ko na lang. The c refers to x bar minus mu divided by sigma over square root of n. Ito siya, standard normal. Yan yung z natin. Ito yung parang z. What about yung ating chi-square? Kulang pala itong space ko dito. So, yung chi-square natin dito, it's actually the expression. Ano yung expression natin? Ibahin na lang natin yung color. Dito ko lang isulat sa baba ha. We have the n minus 1 s square divided by sigma square. Alam natin ito. Having a chi-square distribution with n minus 1 degrees of freedom. So, to construct our t statistic, to construct our t statistic having a t distribution, yung ratio ng dalawa na yan. Makukuha natin itong part na to. Saan natin isulat yan? Ratio. Sige, dito ko na isulat sa kabila. Pink. So, na yan tayo. X bar minus mu divided by sigma over square root of n over yung square root daw. Ano yung u natin? Chi-square siya. So, n minus 1 quantity s square over sigma square. Ano yung s square natin? Ang value ng s square natin, yung s square is what? The summation of xi minus x bar quantity square divided by n minus 1 and then divided by, ano pa yun? I-divide mo siya ng k. Ano yung k natin dyan? N minus 1. So this one will cancel out. I-green na lang natin. This one will cancel out. N minus 1. Pero ang maiwan pa rin dyan, pwede na pala na hindi na diretso pala yung S square. Nandun pa rin yung S square pala. Okay lang pala lang yun. Okay lang, i-pan ko na lang. Sorry guys kung lang diretso lang ako. So we have here n minus 1 over sigma square divided times S square. Kaya na siya divided by its degrees of freedom. Okay, cancel. Okay, yung square root of sigma square is sigma. Square root of sigma square is sigma. So ito mag-cancel din yan. So maiiwan na lang ito. X minus mu. So this is equal to x bar minus mu. Mu is equal to mu sub 0 kasi over square root of S square over n. Take note of mu here. It's mu sub 0. So having a t distribution with n minus 1 degrees of freedom. Okay. Ang question ngayon, how are we going to determine what should be the value of t sub L or t sub u? It says here, say any choice of t sub u will be equal to t sub n minus 1, 1 minus alpha sub 1, and the t sub L is t of n sub 1 alpha sub 2, where alpha sub 1 plus alpha sub 2 will be equal to alpha. Will yield a test with type 1 error probability with exactly alpha for all theta in the null parameter space. And the usual choice here, that our t sub L is equal to the negative of t sub u. Diba? Ano pala yung graph ng ating t distribution? The graph of the t distribution is so similar to the z distribution or the standard normal distribution. Pareho lang. Bell shape, symmetrical, with respect to our mean, no? Symmetrical. Ano nga ang sabi ng z distribution sa t distribution? Diba ang sabi ng z distribution to the t distribution? You may look like me, but you are not normal. Pareho halos sila. So that means, kung mag-determine ka ng parang pareho lang naman, no? Graph nila parang pareho lang naman. So dito ngayon, this is now the t sub u. Here, this is the t sub L. And this particular one should be alpha. Okay? Alpha sub 1 yan siya. Alpha sub 2. Ito pala yung alpha sub 1. This is 1 minus. Kabaliktad lang pala yan. Symmetric na lang, no? Halos pareho yung kanina sa sinabi ko. Okay, so we have that for our size, no? So size na, mahanap natin yung size alpha test. Okay, let us proceed now. Definition. Are you with me?
Yes, sir.
Yes, sir. Okay, let me continue. So a test with power function beta of theta is an unbiased if what? If the beta of theta prime is greater than or equal to beta of theta double prime for every theta prime in the alternative parameter space and theta double prime in the null parameter space. Minsan pag binabasa natin yung definition, hindi natin kaagad maintindihan because we are reading it in a mathematically. So Paano natin basahin dapat ito? A test with power function beta of theta is unbiased, para siyang unbiased, if this one, ano ito? If this 1 minus probability of a type 2 error, no? 1 minus the probability of a type 2 error here is greater than or equal to the probability of a type 1 error. Kasi itong theta double prime nasa null hypothesis, nasa null parameter space. So ibig sabihin, yung beta of theta double prime there, it's the probability of a type 1 error. Ito ngayon, itong theta prime nasa alternative parameter space. So yung beta of theta prime, it refers to the 1 minus the probability, no? 1 minus the probability of a type 2 error. So pwede mo naman sabihin yan na that 1 is greater than, pwede natin sabihin that 1 is greater than the probability of a type 1 error plus the probability of a type 2 error. So let's have an example to this definition. No? The beta of theta prime is greater than or equal to beta of theta double prime. So an LRT of the null hypothesis that theta is less than or equal to theta sub 0 versus the alternative that theta is greater than theta sub 0 has a power function. Alam natin ito, na yung power function natin, we have here beta of theta, it is equal to the probability that our x is an random x is an element in the rejection region for all theta, indexed by theta. In our previous example, example 8.3.3, ito yung rejection region natin when z is greater than that. Okay? Z is standard normal, and we know that our beta or the power function is an increasing function of theta. We see that in the previous example. So it follows that if we're going to consider this, the beta theta is an increasing function, so beta of theta is greater than beta of theta sub 0 because theta is greater than theta sub 0. And then if we're going to look at our null hypothesis, kung titingnan natin yung null hypothesis, yung pinakamalaki na theta dyan sa ating null hypothesis, pwede ang theta can take the value theta sub 0. So the maximum of the power function in the null hypothesis, ito ngayon, the beta of theta sub 0 kasi meron tayong strict, non-strict inequality dyan. So the beta of theta sub 0 is the maximum of the power function beta of t, where t is less than or equal to theta sub 0. Ito yung nasa null hypothesis natin. So di ba ito nasa null? Ito yung sa null hypothesis natin because theta double prime is in the null parameter space. Ito naman yung sa ating alternative hypothesis. Itong part na to. Because it's theta is greater than theta sub 0 here. Ayan, theta is greater than theta sub 0. We have that. Since we're able to show that the power function beta of theta is greater than beta of theta sub 0, therefore our test is an unbiased test. Last na to na page. Pero sabi ko kanina, check muna natin addition, Yahoo. Any questions or clarifications? Inference 8.3 copy. New. Lagyan natin ng new. N. Import. N. Ito. Duplicate. Unbiased. Okay, let me proceed now. Wala man kayang question. So, yung natutunan natin, dinefine natin yung size alpha test. We have the level alpha test, and we have three examples for this definition. Actually, it focuses on the size alpha test. And after that, no, sa size alpha test, we have this definition for the unbiased, the power function to be unbiased. Then let us proceed to the next section, determining the most powerful tests. So in previous sections, we have described various classes of hypothesis tests. Some of these classes control the probability of a type 1 error. So for example, the level alpha test have type 1 error probabilities at most alpha. That's for all theta in the null parameter space. So we control the type 1 error probability. We fix it to a particular level. And then after that, a good test in such a class would also have a small type 2 error probability. So if we have a small type 2 error probability, that means that we have a large power function for theta in the alternative parameter space. So if one test had a smaller type 2 error probability than all other tests in the class, then it would be a strong contender for the best test in the class. And we have this definition. So mag-fix tayo. We set our level alpha. We set alpha or the significance level equal to alpha. Yan yung maximum probability natin. So hanapin na lang natin yung test na may pinakamaliit na type 2 error probability. So let script C be a class of test for testing the null hypothesis that theta is in the null parameter space versus the alternative hypothesis that theta is an element in the alternative parameter space. A test in class script C with power function beta of theta is uniformly most powerful class C test if the power function beta of theta is greater than or equal to the power function beta prime of theta, that is for every theta in the alternative parameter space. Kung ito yung consider natin, pag malaki yung beta of theta compared to this beta prime of theta, ang ibig sabihin yan, mas maliit itong type 2 error dito with respect to beta compared to the type 2 error probability with respect to beta prime. Kaya hinahanap nga natin yung may mas maliit na type 2 error probability. Kung maliit yung type 2 error probability, malaki yung kanyang power function. Okay, so we are comparing the power function for us to be able to determine the uniformly most powerful class script C test. So in this section, the class C will be the class of all level alpha tests. So pwede natin i-set yung significance level natin into alpha. So the test described in definition 8.3.11 is then called the uniformly most powerful level alpha test. So the requirements in definition 8.3.11 are so strong that uniformly most powerful tests do not exist in many realistic problems. But in problems that they have uniformly most powerful tests, a uniformly most powerful test might well be considered it's the best test in the class. Okay, so thus we would like to be able to identify that uniformly most powerful test if they exist. So we have here the following, no, a theorem that describes which tests are uniformly most powerful level of a test in which both the null and alternative hypotheses are simple hypotheses. Simple, hindi siya composite hypothesis. We have this, no, the Neyman-Person lemma, but it is referred to as the theorem 8.3.12. So consider testing the null that theta is equal to theta sub 0. So simple ang ating null hypothesis versus the alternative h sub 1, theta is equal to theta sub 1. So simple din ng hypothesis, no? Alternative hypothesis, where the PDF or PMF corresponding to theta sub I, we have here the joint PDF. And using a test with rejection region R that satisfies the sample point X, an element of the rejection region, if this inequality, we have this inequality, and X is an element of the acceptance region if we have this inequality. By the way, it's better to express it in ratio form. Pwede nang the joint density given considering theta sub 1 F, considering theta sub 0, it would be greater than K. And then the other one, 0 will be less than K. For some K, non-negative. And then our alpha would be equal to, that's actually the probability that X, the sample X is an element of the rejection region in the, ito theta sub 0, in the simple hypothesis, theta is equal to theta sub 0. So in the null parameter space. So we have these conditions, these two conditions. Then any test that would satisfy these two conditions is a uniformly most powerful level alpha test. That's for the sufficiency. And then necessity, if there exists a test satisfying 8.3.1 and 8.3.2 with K strictly not positive, then every uniformly most powerful level alpha test is a size alpha test that would satisfy 8.3.2. Take note, yung sa definition natin kanina, the level alpha test contains the size alpha test. If we have K here exactly greater than 0, if it is greater than 0, then the uniformly most powerful level of the test is also the uniformly most powerful size alpha test. And then every uniformly most powerful level alpha test satisfying 8.3.1, except perhaps on the set A satisfying the probability that X is an element of A, this is equal to the probability that X is an element of A on this alternative will be equal to 0. Let's have another corollary that connects the Neyman-Person lemma to sufficiency. Consider the hypothesis problem posed in theorem 8.3.12. Suppose t of x is a sufficient statistic for our parameter theta. And then g of t is the PDF or PMF of our sufficient statistic corresponding to theta sub I from 0 and 1. Then any test based on this sufficient statistic with rejection region S, a subset of the sample space of T, is a uniformly most powerful level alpha test if it satisfies these conditions. So, pwede din natin masulat ito as ratio. Don't worry, no? Kasi meron tayong example nito. Yung example na illustrating the Neyman-Pearson lemma or the theorem, and then an example illustrating our corollary. So let's proceed. So itong example 8.3.14, this will illustrate the Neyman-Pearson lemma. Okay, the Neyman-Pearson lemma. So say here, let X has a binomial distribution with two trials and the probability of success is theta. We want to test the null that theta is equal to 1/2 versus the alternative that theta is equal to 3/4. So both null and alternative hypotheses are simple hypotheses. So calculating the ratios of the PMFs gives, ayun yung ino-compute natin yung mga PMF. But before computing for the PMF, we're going to compute for our density or the probability. Say f of 0, say theta is equal to 3/4. Yan muna. So we have a combination of 2 taken 0, the probability of success 3/4 raised to 0, the probability of failure raised to 2 minus 0. So combination of 2 taken 0 is 1. So may 1 dyan is 1/4 raised to 2. So 1/16. F, then the possible values of x is 0, 1, and 2. So 1, for 1, you have 3/4. You have a combination of 2 taken 1. Probability of success raised to 1. Probability of failure 2 minus 1. So what we have 2 times 3/4 times 1/4. Okay, so the answer for this is equal to 3/8. F of 2, the last value for x, 3/4. Combination of 2 taken 2, 3/4 raised to 2, 1/4 raised to 2 minus 2. 0. So 3/4 square, and then we have here 9/16. Next, f of 0, considering theta is equal to 1/2 for our null hypothesis. So 2 taken 0, we have 1/2 raised to 0, 1/2 raised to 2 minus 0. Okay, so 1/4. The answer is equal to 1/4. F of 0, 1 pala. F of 1 is equal to 1/2. So combination of 2 taken 1, 1/2 raised to 1, 1/2 raised to 1. So 2 times 1/2 times 1/2. So the answer is equal to 1/2. And then lastly, for x equals 2, theta is equal to 1/2. So combination of 2 taken 2, 1/2 raised to 2, then 1/2 raised to 2 minus 2. So we have here 1/2 square 1/4. So this would imply, natin ngayon that yung f check lang natin para intindihan nyo naman yung solution dyan. Over F, according to our Neyman-Pearson lemma, di ba? Dapat yung numerator natin, okay? Yung numerator natin, this is for the alternative hypothesis. Yung denominator natin dito, itong sa kabila na side, this is for the null hypothesis. So, sa numerator natin. Okay, so this would be equal to what? 3/4, 1/16 divided by 1/4. So we have here 4/16. Okay, verified. Ganun din yung sa pangalawa. When you consider x equals 1, take note in our lemma, pareho dapat yung ating sample point. Diba? Tingnan nyo, pareho yung mga sample point. Yan, yung x dito pareho. Pareho yung sample point. So we have that, verify. So if you choose k to be greater than 3/4 but less than 9/4. So itong 3/4 na to, okay, yung 3/4 na yan, it actually refers to dito, sulat ko na lang ulit if k is greater than 3/4 or 3/4 is less than k, saan man yan? Saan yan na part sa ating, balik tayo sa ating lemma. If it is less than your value k, yung ratio is less than k, that means, ang implication niyan, na yung x is in the acceptance region. No? Based on our theorem. So, ibig sabihin ngayon, na yung x dito, ano yung x dito? It refers that x equals what? X equals 1 is in the acceptance region. When k is less than 9/4, balik tayo sa definition naman. Ay, okay, when k is less than, so ibig sabihin itong part na to, the ratio is greater than k or k is less than. So meaning to say yung x doon, itong x dito sa ratio na to, is in the rejection region. So anong x dito na part? When k is less than 9/4. So ano yung x dito? Yung x dito is what? Sa 9/4? Ito, yung x is what? 2. Yan. Ito, 2. Sa 9/4. X equals 2. It is in the rejection region. So, na-satisfy natin yung ating condition in our Pearson-Neyman theorem. Tama ba? Kalimutan ko. Neyman-Pearson lemma. So, na-satisfy itong dalawa. Itong dalawa niya, na-satisfy siya. And at the same time, we're going to show that this alpha is equal to the probability that x is in the rejection region given our null parameter space. So, ang rejection region natin, that x equals 2. That is why it says here, the Neyman-Pearson lemma says that the test rejects the null hypothesis. Rejection region natin kasi when x is equal to 2. The null hypothesis rejects the null if x is equal to 2 is a uniformly most powerful level alpha test. But what is alpha in this case? Alpha is equal to the probability that x equals to 2 given the theta. Pwede naman natin isulat nito. Alpha is equal to uh, 1/4, no? The probability that uh, x is an element of the rejection region given theta sub 0. But what is theta sub 0? Probability theta sub 0 is 1/2. In that case, diba theta is equal to theta? Ito man yun. Theta is equal to 1/2. So itong 1/2 dito refers to theta sub 0. Itong 3/4 dito refers to theta sub 1 in our theorem. So P of theta, and what is our rejection region? Ito yun, rejection region. X is equal to 2, given that theta is equal to, in our null hypothesis man yan. Yung computation dyan, ito, 2 and then 1/2. Ito na part. So the answer is equal to 1/4. Okay. So we have that, no? When we choose our k to be greater than 3/4 but less than 9/4. Say for example, yung napili mo na k this time is greater than 1/4 but less than 3/4. So we have here 1/4, k less than k, but k is less than 3/4. Dito sa 1/4, diba 1/4 is less than k. So ibig sabihin yung x dyan, in our ratio, yung 1/4, in our ratio, yung x, itong x na to, ang x na yan, is in the acceptance region. So, ibig sabihin niya ngayon that x equals 0 is in the acceptance region or the complement of the rejection region. What about k is less than 3/4? K is less than 3/4. Ang ibig sabihin dito ngayon that x equals, well, sa 3/4 natin, ano pala yan? 1, this is in the rejection region. Up. Sinobra pa. An element of the rejection region. But we know that 3/4 is also less than 9/4. So this would further imply that 1/4 is less than k, less than 9/4. Parang ganon. So this would further imply that in this case, x equals 2 is also in the rejection region. So kaya ang sabi dyan, the Neyman-Pearson lemma says that the test rejects the null, it rejects our null if the value of x is equal to 1 or x is equal to 2. Because it satisfies these two condition yan. May ratio tayo eh. May ratio tayo ng PDFs or PMFs. So that would imply now that our alpha is equal to the probability that x with 1/2 yan. Hindi na lang nakasulat yung 1/2 na subscript, no? Pero nilagyan niya ng given that theta is equal to, ito yun. Pwede ito wala. Ito yung isusulat mo. X equals 1 or 2 given that theta is equal to 1/2. So this would be equal to the probability 1/2 x equals 1 given that theta is equal to 1/2 plus x equals 2, the theta is equal to 1/2. So in this case, 1, and then theta is equal to 1/2, the answer is 1/2. Yung pangalawa, the answer is 1/4. So that's 2/4 plus 1/4. The answer is 3/4. Okay, we have that correct. It depends on the choice of our K. Pili naman tayo ang K, di ba? Sabi doon, that is where K is greater than or equal to 0. Satisfying this. Then choosing K to be less than 1/4. Dito tayo. K is less than 1/4. K is less than 1/4, but this is less than. So ibig sabihin dito, if this is less than 1/4, etong X dito equals 0, nasa rejection region. But 1/4, kasi may ratio of PMFs tayo. 1/4 is less than 3/4. So meaning to say that X equals 1 here is in the rejection region. But 3/4 is also less than 9/4. So that means that our X here equal to 2 is in the rejection region. Okay, so this would imply that our alpha is equal to the probability. Kulang tayong space yata, no? Dito sa itaas na lang, konti. This would imply that our alpha is equal to the probability that X equals 0, 1, or 2. And this is equal to the probability of given 1/2. Pwede natin sulat ditong 1/2. So P of X equals 0, and then 1/2 plus P equals 1 or 2 1/2. So ano yung answer natin kanina? Ano, 1/2, X 0, then 1/2, 1/4. So this is 1/4. Ano yung answer dito? Sa pangalawa, this is 3/4. So the answer is equal to 1. Kaya itong part na to, for K less than 1/4, it yields a uniformly most powerful level alpha is equal to 1 test. But for K, brown. But for K greater than 9/4. So for K 9/4, obviously, wala tayong X dyan. Diba? For K 9/4, or we may say 9/4 is less than K. Yan yung ating, ibig sabihin yan, yung set of all X na elements sa ating rejection region is actually equal to an empty set. Wala ng X, walang value ng X that would be in our rejection region in that case. Kasi less than K value. So in this case, yung alpha natin, so this implies that our alpha, which is actually the probability of our rejection region in this case, no, yung rejection region natin, X is an element of the rejection region. We have 1/2 is the probability of an empty set, 1/2, and the answer will be equal to 0. Lahat ng X natin nakuha naman dito sa part na to when K is greater than 9/4, there is no other X. Walang X dyan. That would satisfy this inequality 9/4 less than k. Okay, kasi dito, sa acceptance region man to dito na part. Okay. Okay, naintindihan ba? 2 to 3:30. Sana diretso lang tayo ha. Tapusin na lang natin tong chapter na to. Para next meeting, last chapter discussion ko. Okay, so we have that. Next, note that if we take k to be exactly equal to 3/4, kung yan ang ipipiliin mo, if k is exactly equal to 3/4, sulat natin dito, maintindihan naman natin itong part na to. If k is exactly 3/4, and we know that 3/4 here is greater than 1/4, but 3/4 is less than, sabihin natin, no, ganun lang sulat natin. If k, mamaya na lang to. 3/4. So, kung ganito yung ating form, so if k is equal to 3/4, but in this case k is equal to 3/4, then 8.3.1 says that we must reject our null for the sample point. So exactly equal siya. Kasi k is equal to 3/4. So pwede siya na k equal to 3/4. If k is equal to 3/4 and then we have this, no, we have this. So ibig sabihin ngayon yan na ito, yung mga values natin dito, that x here equal to 2 is an element of the rejection region. No? Element siya ng rejection region. Ito, kasi less than or equal to siya na k value, so pwede itong x equals, in this case, x is equal to 1. It could either be, no, it could either be x is in the rejection region, or x equals 1 is in the rejection region, or x equals 1 is in the acceptance region. So, hanging yan dyan na part. But 3/4 is greater than 1/4. Okay? Greater than 1/4. So, ibig sabihin, itong part na to dito, that x equals 0, obviously, element siya sa acceptance region. Pero itong dito na part, either siya, either an element of the acceptance region or an element of the rejection region. Yung part na yan. Okay? Kaya sabi dito, says we must reject our null for the sample point. Rejection region natin. We reject our null for the sample point that x equals 2. Rejection region kasi yan. And then accept our null, acceptance, nasa acceptance region when x is equal to 0. Acceptance yan, accept. Kasi complement of R naman. But leaves our action for x sub 1. Kaya hindi siya obvious sa x sub 1. Pero kung pipiliin mo na ang x sub 1, if we're going to accept, dito tayo, orange. If you're going to accept h sub 0 for x sub 1, ito yon sa orange, accept. Yan yung orange. Acceptance sa complement ng rejection region. So we get a UMP level alpha which is equal to 1/4 test as above. So dito lang tayo sa x equals 2, yung rejection region natin. Yan lang yung consider natin. that means our alpha here, kung orange tayo ha, so orange. So orange, yung alpha pala natin dyan, it should be equal to the probability that x equals 2 lang, given our theta is equal to 1/2. Ano yung x equals 2? That's equal to 1/4. Above. Ito yung nakuha natin. Yan. Kasi yung 1 nasa acceptance region. Klaro lang ba yung color? Pero kung i-consider natin yung x equals 1 nasa rejection region. Ito nasa rejection region ito. Oh, sorry. Oh no. Mali pa naman yung akala ko. Shade. Ano dapat pala? Ito. Yan. Kung nasa rejection region siya, kung yung x equals 1 nasa rejection region, so yung alpha natin dyan, yung alpha natin dito will be the probability. Nasa rejection region kasi siya. X equals 1 or 2 given theta is equal to 1/2. And the answer for that is equal to 3/4. Ayan, ito. If x. So it depends on your value of k. No? You choose your value of k, and then you would be able to determine the uniformly most powerful level alpha test. Iba-iba sila, no? Di ba? Yung kung k greater than 1/4 but less than 3/4, so the test that rejects the null if, ito yun, x equals 1 or 2 is a uniformly most powerful level alpha test. But if k is greater than 3/4 but less than 9/4, so the test that rejects the null if what? X is simply equal to 2 is the uniformly most powerful level alpha test, which is equal to 1/4. Pero kung ang k value mo is strictly less than 1/4, ayan, no? Yan yung itong conditions natin. K greater than 9/4, and we choose k equal to 3/4. Okay, so this is an illustration of our Neyman-Pearson lemma. What about the corollary? So itong next part, malapit na tayo matapos. Ilang page na lang. 3 page. Okay, kan tayo. Napamambunin na.
Yes, sir.
Okay, so kaning sunod nga example, this is an illustration of the corollary. So sa corollary nagaingon nga na mangita tag sufficient statistic. So di ba, ingon siya nga, consider a hypothesis problem, and then we have a sufficient statistic, and then if we know the distribution of this sufficient statistic and then corresponding to our simple hypothesis, then we could able to determine the uniformly most powerful level alpha test if it satisfies the inequalities above, and at the same time the probability that this sufficient statistic is an element of the rejection region given our null parameter space. So it says here that x sub 1 up to x sub n be a random sample from a normal distribution with mean, theta, variance, sigma square, and in this case, sigma square is known. So the sample mean, by factorization theorem, alam natin ito, that the sample mean is a sufficient statistic for our population mean mu. Then consider testing. We have two simple hypotheses, both for the null and alternative. And then we have the condition here that theta sub 0 is greater than theta sub 1. And then the inequality. Sa itong inequality na to, this actually refers for the inequality for us to be able to obtain the rejection region. No, this is for the rejection region. Tingnan natin ulit. Yung inequality na yan is for the rejection region. Okay, tingnan natin ulit yung ating theorem. Greater than. Oh, ito. Ito yon. So, it's an element of S. S is the rejection region. So, this is for the rejection. Yan yung inequality na yan is for the rejection region. So, sorry. Ano nga yan? Okay. Solve natin yung rejection region. Paano natin i-determine yung rejection region? Dapat i-determine natin yung ating statistic. So we have this sufficient statistic. X bar should be less than this expression. And how did we able to get this value? We have g of x bar given theta sub 1 greater than k, g of x bar given theta sub 0. By the way, ano nga yung density ng ating sample mean? Normally distributed with mean theta and variance sigma square over n. So kung hahanapin natin yung density niyan, that's exactly equal to what? 1 over the square root of 2 pi sigma over square root of n e to the what? Negative. Okay? We have negative x man lang ginamit natin, no? Minus theta quantity square over sigma square over n. So dito na natin isulat yung n. Sigma square. Okay, we have that. So balik tayo dito. So ano yung g of x? When we say theta sub 1, i-replace lang natin yung ating. So that would be equal to what? Square root of, sulat na natin na buo na sa square root, 2 pi sigma square. Tingnan ko yung blue. So we have here the exponential of what? Negative n x bar. X bar yung gamit, no? Okay, x bar kasi yung sa sample natin dito. Minus theta square, theta sub 1. Theta sub 1 yan. Minus theta sub 1 over sigma square. Greater than k. For theta sub 0 tayo. So, square root of n over 2 pi sigma square. Exponential of negative n x bar minus theta sub 0 over sigma square. Okay? So this one will cancel out. So ano maiiwan na lang? So we have now the exponential of what? Pwede natin may sulat. Negative n x bar minus theta sub 1 square over sigma square. Lagay natin yung sa baba, yung sa right hand side. So magiging plus yan using the property of exponential. X bar minus theta sub 0 quantity square over sigma square. And this is greater than k. So apply yung logarithm. Pag-apply natin ng logarithm dyan, so what do we have? So negative n x bar minus theta sub 1 square plus n x bar minus theta sub 0 square. Okay? So we have greater than, meron tayong log of k, but meron tayong sigma square. Sigma square. Sorry, may 2 sigma pala dito. Di man kayo nag-comment, guys. Naman na siya 2 sigma din ni. Wala pa naman tingog dayon ba? Okay, 2 sigma square. So factor out n. So negative x bar square minus 2 x bar theta 1 plus theta 1 square, and then plus x bar square minus 2 x bar theta sub 0 plus theta sub 0 square. This would be greater than 2 sigma square over n log of k. Okay, we have that. And then if we're going to distribute ito, this sum is equal to 0. So yung may iwan dyan, we have here the negative 2x bar theta 1 minus 2 x bar theta 2. And then minus theta sub 1 square plus theta sub 0 square. 2 sigma square over n log of k. Okay, so factor out x here. So pwede natin x bar pala. So we have here 2 theta sub 1 minus 2 theta sub 2. Should be greater than 2 sigma square over n log of k, and then minus, okay, theta sub 0 square, transpose it on the other side, plus theta sub 1 square. Therefore, x bar would be less than siya of what? 2 sigma square over n. We have the log of k minus theta sub 0 square plus theta sub 1 square divided by 2 times theta sub 1 minus theta sub 2. By the way, but not change yung the sense of inequalities being reversed. Why? It's because the reason that we have theta sub 0 is greater than theta sub 1. So if and only if, pareho lang naman yan, that 0 is greater than theta sub 1 minus theta sub 0. So ibig sabihin yung ating denominator, itong part na to, ito, ayan, negative yan siya because 0 is greater than that expression. That is why the sense of inequality is being reversed. We're able to get that. So ibig sabihin ng ating rejection region dito, when our statistic big X bar is less than the expression on the right-hand side. Yan yung rejection region natin. Di ba sabi ko? That's that inequality is for our rejection region. So the fact that theta sub 1 minus theta sub 0 is negative was used to obtain this inequality. The right-hand side increases from negative infinity to positive infinity. Okay? As x increases from 0 to positive infinity. Because if we're going to look at the graph of the logarithmic function, ganyan man yung graph natin. Okay, this is for the log of k. Parang log of k lang yan. So for k, ito yung k natin, k from 0 to positive infinity lang. So dito lang yan magsimula. So yung log of k, yung value ng log of k is from negative infinity to positive infinity. So kaya yung ating kandiyan, no? Yung right-hand side, it says there, it increases from negative infinity to positive infinity as k increases from 0 to positive infinity. So thus, by the corollary 8.3.13, the test with rejection region that the x bar is less than c. So itong c dito, it actually refers to this expression. Okay, that whole. It is it's less than x bar is less than c is a uniformly most powerful level alpha test where says there where our alpha would be equal to the probability of the uh, rejection region given the parameters, given the null parameter space, no? On the null parameter space theta sub 0. Kaya yun nating, so we have that. If a particular alpha is specified, then the uniformly most powerful test rejects the null if c, if x bar is less than c, will be equal to this expression. Yan, ito man ang sabi niya, no? Kailangan ito masatisfy. The probability that theta sub 0 would be x bar less than c. Okay? Take note that if we have small x bar here, less than c, if and only if, what do we have? We have x bar minus theta over sigma over square root of n would be less than c minus x theta sigma over square root of n. Since we know that x bar has a normally distributed with mean theta and variance sigma square over n. So if and only if, ito naman siya, this would be small z less than c minus theta sigma over square root of n. Yan. So if we're going to compute now the probability of theta sub 0 x bar is less than c. Yan. Equal to alpha ito, no? Equal to alpha. This is equal to what? The probability, okay, that theta sub 0, but this time, z na tayo. Kasi ito yung condition natin sa itaas. So z, capital Z na, capital X bar man to, would be less than c minus theta sub 0. Okay? Nilagay na kasi natin yung theta sub 0 dyan, divided by sigma over square root of n. So this is equal to the probability at theta sub 0 that z is less than, pwedeng ganun, yo, is less than the negative of z alpha. And we know that this is equal to alpha. This is equal to alpha. Yeah? So this would further imply that the negative z sub alpha would be equal to, okay, equal yan siya sa c minus theta sub 0 over sigma over square root of n. So what do we have? Negative sigma over square root of n negative z sub alpha is equal to c minus theta sub 0. And this should further imply that c here, okay, is equal to theta sub 0 minus z sub alpha sigma over square root of n. Okay, so the test with rejection region x bar less than c is a uniformly most powerful level alpha test. And what should be that value of C for this test? Yan yung C, equal to theta sub 0 minus Z alpha sigma over square root of n. Okay, so hypotheses such as H sub 0, ito lang, nasabi ko na ito before. Pag it's not a simple hypothesis, then we have a composite hypothesis. If the null hypothesis, no? If the hypothesis have, no, we have here, theta is greater than or equal to theta sub 0, no? And to say we have a large value of theta, and then when theta is small, theta is less than theta, we have a one-sided hypothesis. Pag ganito yung ating hypothesis, then we have a two-sided hypothesis. Next definition, this is the last part. Okay, kapit na matapos. So a family of PDFs or PMFs for univariate random variable T with random but real valued parameter theta has a monotone likelihood ratio, MLR, if for every theta sub 0 greater than theta sub 1, this ratio, G of T given theta sub 0, theta sub 2, divided by G of T given theta sub 1 is monotone. When you say monotone, it's a non-increasing or non-decreasing on T, okay? Rather, on the function of T. So this function of T, pwede natin sabihin yan, this is a T of the function, small t. Pero kung variable T na pala yan, sorry. Hindi natin pwede gamitin yung T as a function kasi yung T is, we can use other variables. Say, ano yung dapat na R na lang? R of T. So it's a function of T. So itong T here, small t, is the realized value of our random variable. So on this given set, note that C divided by 0 is defined as infinity if 0 is less than C. So many common families of distributions have an MLR. For example, the normal with known variance and a known mean. Pwede yan, no? Pwede po na unknown mean. Pwede po na unknown mean and then known mean and then unknown variance. Pwede yung ganun. Poisson, binomial, all have an MLR. Indeed, any regular exponential family says here as an MLR with W as a non-decreasing function. See that in exercise 2.25. Exercise. Well, let us try. Let's have an example. Kunwari, meron tayong random sample. We have these random variables. Para lang explain natin, no? Random variables having Poisson distribution with parameter lambda. So, meron tayong random sample na x of I. Yan ang given. So, yung density nito, si x lang isulat ko niya sa x sulat. So, we have here e to the negative lambda, lambda to the x over x factorial. Okay, so ang sabi dyan, we have the monotone likelihood ratio. So, this is what we call the ratio. Pwede natin sabihin ito, this is the likelihood ratio. Okay, the likelihood ratio. So, this would imply, itong part na to, this would imply that the joint density, yung joint density nito, given our parameter lambda, would be equal to what? It is the product of e to the negative lambda, lambda to the xi over xi factorial, I from 1 up to n. Okay, meron tayong random sample, sabi ko kanina. So this will just be equal to what? This will just be equal to e to the negative n lambda, lambda to the summation of x sub I over the product of the x sub I factorial. Okay, so ngayon, titingnan natin yung likelihood ratio. Kung monotone ba siya, so likelihood ratio is equal to what? Yung, yung f of x given lambda sub 1. Okay, so we let lambda sub 0 to be less than lambda sub 1. Yan yung assumption, itong part na to. Or lambda sub 1. I-follow na lang natin kung anong nakasulat sa let what? Let lambda sub 1 to be greater than lambda sub 0. Yan, lambda sub theta sub 2 greater than theta sub 1. 0 lang yung ginamit natin. Over f of x lambda sub 0. So, replace lang natin yung lambda doon sa ating joint PDF. So, e to the negative n lambda. Wala kasi example sa book, no? Ito na lang, sulat lang. 1, lambda sub 1, the summation of x sub I. Over, ano ba siyang over? Pi of x sub I factorial divided by e to the negative lambda sub 0, lambda sub 0, 1 to 1, the summation of x sub I over the product of x sub I factorial. Obviously, this would cancel out. 1. Then we have what? Pwede natin masulat na e to the negative n lambda sub 1 over e lambda sub 0. And then we have lambda sub 1 over lambda sub 0 quantity raised to the summation of x sub I. Okay? Diba sabi sa definition, this likelihood ratio, yung red, no? This likelihood ratio is a monotone function. Sabi dyan, is a monotone function of t. So in this case, ito, we know that is a monotone, is an increasing because we know that this expression is greater than 1. So a value greater than 1, we raise that to the summation of x sub I. Okay. Obviously, that would be an increasing function for this. So is an increasing function, sulat ko na lang dito ha, is increasing, it says here, monotone, is monotone in the function, it says here, in the function of t, in the function of, but in this case, it's x. What is this function of x? So, pwede natin isulat na this function of x is this function. Hindi siya t. Yung r of x natin is a function of x is equal to what? It's the summation of x sub I. Yan yung, it's a function of x. May bar pala yan. It's a function of x. So that is, the r of x is the summation. Ito yun, makikita niyo. You have that, the summation of x sub I. Since, the reason for this, since lambda 1 over lambda sub 0 is greater than 1. Therefore, the Poisson families have a monotone likelihood ratio. Okay, you try to answer that, no? Yung problem, say for example, normal, known variance and unknown mean. How do you going to show that it has a monotone likelihood ratio? What about for a binomial? Okay. a binomial have a monotone likelihood ratio. Okay, let us proceed. Theorem. This is the last theorem for this chapter 8.3.17. Saan na nato, no? Consider testing the null versus the alternative. Okay, so we have here a composite or null hypothesis. This is a one-sided test. Take note of that. Suppose T is a sufficient statistic for theta, and the family of PDFs or PMFs of T has an MLR, has a monotone likelihood ratio. Then for any T sub 0, the test that rejects the null, it says here, if and only if T is greater than or no, greater than T sub 0. Take note, no? Etong greater than, it depends on the alternative hypothesis here. Now, this should be the statistic T should be greater than, this sufficient statistic should be greater than T sub 0. And that would reject our null hypothesis. And that test is a uniformly most powerful level alpha test, where, okay, alpha is equal to the probability that T is greater than T sub 0 on the null parameter space. Theta sub 0 yan, yung pinakamalit yan. Pinakamalaki kasi yung theta sub 0 on the null parameter space. So analogous argument, it can be shown that under conditions, theorem 8.3.17, the test, kung titingnan nyo, magkabaliktad yan dyan sa theorem. So theta is greater than or equal to theta sub 0 in favor of the alternative that theta is less than theta sub 0. So this time, ito na ngayon. Less than, then we have here. So if and only if. So we reject if and only if this. T is less than T sub 0 is a uniformly most powerful level alpha test, where alpha can be computed as this probability. Okay, mahuman na tani, dali lamang kayo. So to illustrate this Carlin-Rubin theorem, this example here, kanina example, kani siyang gi-verify niya. Kaya kung tanaw ni mo yung null hypothesis, mo man ni, pareho ana. Pareho forma, no? Mo na yung null hypothesis. So yung alternative po, pareho gyapon na ni sa. So continuation of example 8.3.15. Consider testing the null hypothesis h sub 0 prime that theta is greater than or equal to theta sub 0 versus the alternative that theta is less than, using the test that rejects the h sub 0 prime. And we have this in example 8.3.15 na ito yung rejection region nato. Based on sa example, katong rejection region nato na dapat ang value sa atong sufficient statistic should be less than. Nakuha natin isa example, no? Moni, resolve na to ganina kung nakainumdum mo. Hindi na ako ibalik. Kaya basin na malibat mo nga si liyok-liyok ang kan. Ang kaning ako ang PDF nga file. So pwede nyo na ma-check. Muna yung rejection region kung ang statistic value x bar equal to that. So the test that rejects. So tinuod man. Kay mao man niya to ang alternative hypothesis based sa to ang analogous argument kani. Kani oh. Alternative hypothesis. And we have shown that our sufficient statistic x bar is the sufficient statistic. Diba? According sa theorem na to, sufficient t is a sufficient statistic. So xt here, this is the sufficient statistic. So kani siya mo niya to ang x bar. It's less than, so mo ning ginapasabot niya na t sub 0. So it rejects. So automatically we can conclude na-solve naman nato ang rejection region diyan because x is a sufficient statistic. Kanilang wala nato ma-show show that the family of means or X bar or the X bar has an MLR. Wala lang na mapapakita. Kaya mao man ang kinahanglanon sa tuang Carlin-Rubin theorem. Pero kabalo man ta na ang kaning X bar normally distributed ni siya. Mao ni giingon sa remark ganina dinhi. For example, the normal all have an MLR, known variance and a known mean. So wala lang napakita. So you try that. Mao po ni sa to ang sample mean. So we know that the sample mean has an MLR. That's in exercise 8.25. Therefore, according to the Carlin-Rubin theorem, it follows that the test is a uniformly most powerful level alpha test in this problem. Yung sufficient statistic is very important. And then after that, if you can, by this statistic, we're able to determine our rejection region. Then based on this statistic and based on our rejection region, and then using the theorem, we can therefore conclude, based on the theorem, as I have said, that a test could either be a uniformly most powerful level alpha test. Any questions or clarifications? May kulang pa pala dito, no? So as the power function of this test, we have this power function, it says here, the beta of theta, that's the power function. It's a function of theta. It's the probability that, equal man, the probability that X is an element of the rejection region for all theta. But it is our rejection region, that is based on our sufficient statistics, we have that. And then it's a decreasing function of theta. Okay, it's a decreasing function of theta because theta is a location parameter in the distribution of the sample mean. So the value of theta is given by not theta, the value of alpha, because this is the alpha for the size alpha test. According to our definition, it is the supremum of the power function beta of theta in the null parameter space. And if we look at the null parameter space, because the beta function here is decreasing, it is decreasing, so it's a decreasing function of theta, then it's being maximized or supremum at theta sub 0, and that would be equal to alpha. Nakasulat dito for the last remark, no? Although most experimenters would choose to use a uniformly most powerful level of a test if they knew of one, but for many problems, there is no uniformly most powerful level alpha test. So that is, no uniformly most powerful test exists because kasi yung class of level alpha test is so large that no one test dominates all other in terms of power. So we consider a class of level alpha test, but we're going to consider, i-restrict naman natin. After restricting it to a class of level alpha test, kung hindi pa tayo nakakuha ng uniformly most powerful test, by restricting to the class of level alpha test, pwede na tayong mag-restrict ulit. Say we're going to consider, we consider a subset of this class of level of a test, and attempt to find a uniformly most powerful test in this subset. Say anong kaya na subset ang i-consider natin? Say we're going to consider a subset that is the unbiased tests. So maghahanap tayo ng uniformly most powerful level alpha test for all the unbiased tests. Just like we did in the point estimation. Consider tayo ng mga unbiased point estimators. And the same steps pa rin. You have only one example in the book. Pwede nyo siya i-refer yung last example nitong chapter na to, considering an unbiased test. Okay, so guys, thank you for attending. Any questions or clarifications? Sinur, Hanifa, do you have any question?
Wala po, sir.
Wala na, sir.
Okay, so to wrap it up, dali lang kayo, no? Pag nag-define taog ka ng size alpha test. Then we also define a level alpha test. And then after that, we have an example for the size alpha test, 3 examples for the size alpha test. Okay, showing that we have a test, no? We have a size alpha test. And then after that, we define a power function to be unbiased. So if the power function beta of theta is unbiased, then we produce an unbiased test here. An unbiased test. That means that the power function beta of theta prime is greater than or equal to the power function beta of theta double prime. Yung theta prime nasa alternative parameter space, yung theta double prime nasa null parameter space. And we have an example illustrating that definition. Then after that, we proceed to the most powerful test. We have a definition for the most powerful test. We just consider a test, no? A class of test, say a level alpha test. That means we restrict it to a particular significance level or level of significance, and then we're going to determine the most powerful test on that class. So in this case, we consider simple null and simple alternative hypothesis, and we use the Neyman-Pearson lemma. And we have an example illustrating this Neyman-Pearson lemma using the binomial test. And then we have also the corollary. That means of the Neyman-Pearson lemma. That means we're going to determine the sufficient statistic for our parameter. And then we're going to construct these inequalities, satisfying these inequalities. And if it satisfies these inequalities, at the same time, the probability of the rejection region is equal to alpha, then we obtain a uniformly most powerful level alpha test. So we have an example also for that corollary. Okay, gamit natin no, sa yung uniformly most powerful normal test. And then lastly, we have this definition of a monotone likelihood ratio. Okay, dapat i-determine natin no, that this likelihood ratio is monotone. It could either be increasing or decreasing in a function of the random variable. And then we have an example considering the Poisson family. And then lastly, we consider the Carlin-Rubin theorem. We make use of the monotone likelihood ratio for us to be able to determine the uniformly most powerful level alpha test. Okay, so that's all for this afternoon. No questions so far? I'm going to